Welcome to a new video of absolute values, guys. This is a little bit of a twist on looking at graphs for absolute values. We thought it would be beneficial for you guys to see how absolute value equations are typically solved, maybe in a little bit more of an advanced way compared to what you've maybe done in Algebra 1. So we're going to talk conceptually about what absolute values mean. So as we learned, graphing absolute values on an XY coordinate plane is not that hard. But there's this underlying idea that's going to be really important in our next chapter. And that idea deals with distance. Absolute values inherently talk about distance from zero. And distance itself can never be negative. So the immediate output of an absolute value will always be positive. But how does that work maybe visually? As you can see, we have a single axis, a number line. And this number line deals with x values. If I gave you the problem, the absolute value of x equals 7, what potential numbers might work in that situation? If you said 7, or maybe -7, you'd be right. Because if I put those in to the absolute value, the output that I wanted is correct, 7. Now what if I did something different? Does it only work with 7? Well, what if we tried 1.5? So the absolute value of x equals 1.5. That says I just want some points that are a distance of 1.5 from the origin. And so the values of 1.5 and -1.5 both satisfy that condition. It doesn't matter if you go to the left or to the right. Absolute values discuss distance. Direction, who cares? So plotting these points on our number line allow us to see that -7 and +7 are both equidistant from that central 0 point. Same thing with 1.5 and -1.5. They're 1.5 units below and above, but distance doesn't care about direction. So it's this idea of sometimes there are multiple points that might satisfy the requirement that gets us into an interesting idea. Sometimes when we're solving absolute values, we're going to have this branching idea where we could have one possibility or maybe another possibility. And so we might get multiple solutions for these types of questions, which is pretty cool. If we look at the first problem, we want you guys to create some simple problems, meaning like the absolute value of x equals, and then something, that has two solutions, one solution, and then no solutions. How are these different situations set up? How are they similar or unique? So the first situation of two solutions, we've already done a couple of those. So we can have the absolute value of x equals any number. So maybe we'll just choose 3, so that values for x that would satisfy this would be 3 and -3, two different possibilities. If we look at this second situation where we just have one solution, that might be a little trickier. To set this up, it'd have to be the absolute value of x equals 0. 0 is the only solution that would make that true. So that's our one solution possibility. The last type of problem where there is no solution, that might be a little trickier. If I have the absolute value of x equals, it takes a negative number to make this not true. Absolute values always produce something that's positive, and so setting them equal to, trying to force them to equal a negative, never will work. So maybe the absolute value of x equals -5. That won't ever work. It's impossible. Now, I'm not saying that negatives aren't used with absolute values, but when you have an absolute value itself equal to a negative, there's no solution. What would maybe be the one way you could force this to work? How would you have to adjust a problem like that? Well, if you really think hard, putting maybe a negative in front of the absolute value would get this to sort out. So an absolute value itself is positive, but the negative negates the positivity of that number, and so you could have a negative equals a negative. That would work. So an example of negative, the absolute value of x equals -3, that's okay, because the negative is changing the output of the absolute value overall to a negative answer. So let's dive into some of these solving questions, and you're going to see the process is very similar to what you did in Algebra 1. So we might be brushing off a little bit of dust here. Question number 2 says, the absolute value of 2x equals 14. Now, typically I'll just scribble out whatever's in the middle. Okay, to start, I want you to think about the logic of this statement. And so, the absolute value of something equals 14. Well, what possibilities could I maybe be dealing with in there? And if you said, well, the distance needs to be equal to 14, and so negative 14 and positive 14 are both that far away from 0, you are thinking exactly how we want you to think about these problems. The inside could be two different things. And so we're going to have these two branches. Whatever the inside is, we could have it equal to the positive case of 14, or whatever's inside, we could have the negative case, which would be equal to negative 14. And so writing that out, it would just be 2x equals 14, and then 2x equals negative 14, because 2x was what was inside. If we go over to the positive case, we're going to solve this. We're going to work our way down to an answer. So we're unpacking the order of operations. We're reversing it in order to get down to the variable that we want. So in this case, we just divide by 2 on the left and the right. 14 divided by 2 is 7. If we go over to the negative case, we're also going to divide by 2 here. You'll see that there are similar steps on both sides. And dividing negative 14 by 2 produces negative 7 as a result. And so 7 and negative 7 are the two solutions? Doesn't that seem weird that we have two answers here? Well, if you're a little concerned, it's always nice to maybe check your work. Plugging those x values back up into the original equation, if we get something that's true, then we can breathe a sigh of relief. But if the problem doesn't quite work out and it's unbalanced, maybe we made a mistake and we'll have to try again. So taking 7 and putting it in, the absolute value of 2 times 7, meaning 14, the absolute value of 14 is 14, and so that checks out. For the negative case, putting negative 7 in, 2 times negative 7 is negative 14. If I have that in absolute values, that becomes 14 itself, and 14 is equal to 14. So both of these solutions were correct solutions. Now you don't have to check every single problem, but if you're ever worried or concerned, or it looks funny, it might be worth your time. Let's try number 3. For this problem, I have the absolute value of x minus 3, and that's equal to 9. So again, kind of scribble that x minus 3 out. Something in there just needs to be equal to 9 as an output. So the something in there could be 9, or it could be negative 9. This is our branching logic. So the positive case would say x minus 3 could be positive 9, and then the negative case says x minus 3 could be equal to negative 9. If we're going to go back and solve the positive version, all we have to do to get rid of the minus 3 is add 3 to both sides. So 9 plus 3 equals 12. Pretty simple. For the negative case, I'm going to add 3 to both sides, but negative 9 plus 3 is negative 6 as a result. So my two solutions are 12 and negative 6. You might have been tempted from the first question to say that you'll always get one number and its opposite, but that's not necessarily true. If we are moving the x's, you might get answers that are equidistant from some central point, not necessarily 0. 12 and negative 6, if you were to check them, both work. So try not to make stereotypes from your questions. Be open to exploring how they work and trying to understand deeper the different situations that you might find. Let's look at number 4. It says the absolute value of 2x minus 4 equals 12. Since the absolute value is all by itself, that's the goal, is to get that isolated, we can branch out to the positive and negative case. So the 2x minus 4 could be 12, or the 2x minus 4 could be negative 12. We have the positive and the negative cases here. If we go over to that positive branch, 2x minus 4 equals 12, I have to get rid of the adding and subtracting first, so I'll plus 4 on both sides. 12 plus 4 is 16. So if I have 2x plus 16, you just divide by 2 on both sides, and 16 divided by 2 is 8. Over on the negative branch, so 2x minus 4 equals negative 12 here. If I add 4 and add 4, negative 12 and positive 4 make negative 8. If I take and divide by 2 on both sides to get the x by itself, the solution for the negative branch is negative 4. So 8 and negative 4, if you check those, both work awesome. Let's ramp up the intensity here a little bit. Question number 5. I have a negative and then absolute value of 3x plus 2 equals negative 7. Now, a lot of people will say, whoa, Mr. Johnson, we can't do this one. There's a negative on that one side. We can't equal negative 7. That's bad. Well, if you're saying that in your head, you missed an important detail. Remember, we can equal negatives if there is a negative in front of the absolute value. Because those are positive, the negative will help solve this issue. And so this is an okay problem. In fact, we're going to get rid of the negative entirely here in a moment. To get the negative off both sides, you could multiply by -1, or I like to divide by -1. It's going to do the same thing in the end. So dividing by -1 on the left and the right produces this equivalent problem. The absolute value of 3x plus 2 is equal to 7. That looks so much better. It looks like the rest of our problems. So at this point, we can branch to the positive and the negative case. The positive case says 3x plus 2 equals 7. The negative case says 3x plus 2 equals negative 7. So if I subtract 2 and subtract 2, I get 3x equals 5. Now, 5 and 3, you might be wondering, did we do something wrong? Not yet. To get rid of the 3 and get x by itself, you divide by 3 and divide by 3, and our answer is 5/3. Is it okay to have fractions as an answer? You betcha. Fractions are really important. You can't be racist against fractions, okay? You gotta be accepting of any number. All of that stuff is good stuff, okay? The more the merrier. Fractions are friends, not food, guys. Enough silliness, though, and let's look at the negative branch. If we have 3x plus 2 equals negative 7, subtracting 2 from the left and the right, negative 7 and negative 2 make negative 9. Dividing by 3 to get x by itself, negative 9 divided by 3, a nice whole number. Whatever, I get negative 3 as my solution. So 5/3 and negative 3, if you're a little uncomfortable, check those. You'll see that they work. So don't assume that the answers you get are going to be positive of a number and the negative of that number. Don't assume that they're both going to be positive. You have to kind of go through the process and just undo the order of operations. Let's look at the problems on the back. We'll see how those work. Number 6. 2 times the absolute value of 3x minus 2 equals 14. Now that 2 in front, bad news. I need to get rid of that so the absolute value is by itself. So I'll divide both sides by 2, the left and the right. 14 divided by 2 equals 7. And so now I have the absolute value of 3x minus 2 equals 7. I can branch out at this point in time to the positive and the negative versions. So 3x minus 2 equals 7. This is my positive branch. I'm going to go ahead and add 2 and add 2. 7 plus 2 is 9. Dividing by the 3 that was with the variable, 9 divided by 3 produces 3 as an answer. One solution down. Now we have to try the negative branch. So 3x minus 2 equals negative 7 here. I'm going to go ahead and add 2 to both sides. Negative 7 plus 2 is negative 5. 3x equals negative 5 means I need to divide by 3 on the left and the right. And so this solution is negative 5/3. If you were wondering, like, boy, those numbers seem familiar, it's kind of the same version as the prior question, except that the signs are flipped in the end. Kind of weird that it worked out that way, but some questions will be like that. Number 7. Look at this closely. This says the absolute value of 3x plus 4 equals negative 3. Now, a lot of times, students will be working ahead, and I'll ask them, is this even possible? Or someone will suggest that maybe this isn't a good question. And I'll say, great observation. Because we have an absolute value equal to a negative, this isn't possible. Absolute values always produce something that's positive. There's not a negative in front to adjust it to be negative. And so this question has no solution. Don't put 0. 0 is a number. No solution says nothing will ever work. You could search your whole life for x values, and you'll never find an x value that makes this equal negative 3. Now at this point, I would kind of turn around and look at all my students, and some students would be erasing their papers frantically, like, uh-oh. What would happen if you tried to solve this? All right? Does your paper catch on fire? Does your pencil explode? What's the consequence? Well, if we go ahead and just solve it like normal, you can see 3x plus 4 equals negative 3. You would subtract 4 and subtract 4. You get 3x equals negative 7, and you divide by 3, and you get this fraction, negative 7/3. Well, we've had fractions before, so people would circle that. They'd say, ooh, that's okay. Then it's the negative case. And this is where you got to be careful. 3x plus 4 equals a negative 3, which makes it a positive 3. If I go ahead and subtract 4 from both sides, 3 minus 4 is negative 1, and then dividing by the 3 in front of the x, I get negative 1/3. Ooh, so a fraction and a fraction? Well, that's not a big problem. The problem happens when you check those numbers. So students who make this mistake don't check their work. If you plug in negative 7/3, the 3's will cancel out, leaving negative 7 plus 4 in your absolute value bars. Negative 7 plus 4 is negative 3. But think about the absolute value of negative 3. That's not equal to negative 3. And so you can't use that number. No way. Doesn't work. But what about the other solution? Maybe it works. So if you take negative 1/3 and plug it in for x, the big 3 and the 3 in the denominator cancel out, leaving negative 1. Negative 1 plus 4 is 3. Remember, this is all in absolute value bars. So the absolute value of 3, is that equal to negative 3? Absolutely not. On no planet is it ever going to work. And so if students make this mistake, they just went about their business assuming, and they didn't check their answers to make sure that it was mathematically true. There is no solution for problem number 7. Be on the lookout for questions like those, because if you get one, you can flip a table and be like, Mr. Johnson, how dare you give me an impossible question? Don't really do that, but in your head you can flip a table. Good work. Let's try maybe question number 8. Question number 8 says 7x plus 4 divided by 8. And that's equal to 3. The dividing by 8 is usually what people get stumped by, but it's easy to get rid of dividing. You just multiply. You do the opposite operation. And so multiply by 8 on the left and the right. 3 times 8 is 24, and the 8's cancel out over on the left-hand side. So now it looks like this. The absolute value of 7x plus 4 equals 24. Now I can go ahead and get my positive and my negative branch. On my positive branch, 7x plus 4 equals 24. On the negative branch, 7x plus 4 equals negative 24. Going back to solve the positive version, you subtract 4 from both sides, leaving 20. If 7x equals 20, you divide by 7. And I know 20 isn't nicely divided by 7, so you can leave it as a fraction. Fractions are fine. If you're more of a decimal person, then you could give the decimal version of this. So x equals 20/7. For the negative version, you're going to subtract 4 on both sides, just like we did in the positive version. You get 7x equals negative 28, and then when dividing by 7 here, 28 is a multiple of 7. We get negative 4 as an answer. With question number 9, some people want to say that there's no solution because they look inside the absolute value and they see negative 8x. Well, that doesn't really do anything because the last step you'll just divide by negative 8. So you have to just be aware of when absolute values are equal to negatives. That's bad. This problem's okay. So in order to start this, I need to get rid of the plus 8 that's at the end. So I'm going to take 80 and I'm going to subtract 8. Now I'm left with 3 times the absolute value of negative 8x equals 72. The 3 in front needs to be shushed out of the way, so I'll divide by 3 on the left and the right. 72 divided by 3 is 24. So here's where we're at. The absolute value of negative 8x equals 24, and now I can branch out because the absolute value is isolated by itself. So the positive branch says negative 8x equals 24, and the negative branch says negative 8x equals negative 24. If you divide by negative 8, in fact, that's the only step in both of those branches that's still left to do. On the positive version, I get negative 3. And then doing the same thing on the negative version, I get positive 3. So my answers here are 3 and negative 3. 2 solutions. Question number 10 has several steps incorporated here. So it says 6, the absolute value of 1 minus 5x, and then minus 9 after the absolute value bars, equals 57. Now going backwards through the order of operations, it's clearly that minus 9 that needs to be dealt with right away. So I'll add 9 to both sides. 57 plus 9 is 66. So when I have 6 times the absolute value equals 66, dividing by 6 on both sides is going to work in our favor. So to the left and the right divided by 6 produces 11 on that right-hand side. So this is where we're at. The absolute value of 1 minus 5x equals 11. We can branch between the positive and the negative cases, and so 1 minus 5x equals 11, and 1 minus 5x equals negative 11. That's the negative branch. If I go ahead and start to solve, getting rid of the 1 is the first thing you do. So it's positive, that means subtract 1 and subtract 1. 11 minus 1 is 10. And here's where people will make a mistake. They'll just bring down 5x, but what was directly in front of the 5? Negative sign. And that negative sign has to carry down with it. It's a negative 5. If you think about adding a negative 5x versus just subtracting 5x, they're the same. We're going to divide by the negative 5, and so 10 divided by negative 5 equals negative 2. If I take the negative branch, 1 minus 5x equals negative 11, subtracting the positive 1, subtracting the positive 1, that makes negative 12. Negative 5x equals negative 12. If you divide by negative 5 on the left and the right, the negatives are really the only thing that kind of cancels out. And it doesn't reduce because 12 and 5 are incompatible as a numerator and a denominator. So the fraction that you're left with is 12 fifths. You could say 2.4, but it is positive because the negative and the negative make a positive. Last problem on the notes, problem number 11. We have the absolute value of negative 2x all over 3, and that's equal to 6. So that 3 in the denominator causing us some issues. So we'll go ahead and we'll multiply on the left and the right by 3 to get rid of it. Having fractions in your problem is not really that much fun. So once I multiply by 3, I have the absolute value of negative 2x equals 18. This is a spot where you can branch out and cover the two situations, because remember, whatever's inside just has to be 18 or negative 18. And that's where we get the two branches. So negative 2x equals 18 means divide by negative 2. Those numbers are attached, so dividing is what you do there. 18 divided by negative 2 is negative 9. The negative version, negative 2x equals negative 18. Dividing by negative 2 again, a negative divided by a negative produces a positive 9 in this case. So my answers are 9 and negative 9. Hopefully with all these questions, you see kind of the general pattern of how absolute values can split and have these multiple branches or multiple paths to get to the solutions. Both solutions are really important because remember, distance could be on either direction when you're dealing with absolute values. If you had to brush off a little bit of solving dust or some of the cobwebs off in the back of your brain, then that's good. These notes are excellent for getting back in the habit of solving equations. At the bottom of these notes is actually kind of a hint, something that will come up later. And in the past, it always seems a little bit like voodoo magic when this comes up, like what is going on? And I think these notes will kind of provide a little bit more of a bridge to understanding why it works later in the semester. So pay attention. There's another way to do absolute values. It's kind of a more advanced way, and people don't use it because it's more work. So watch. If I took the absolute value of negative 8, it's pretty easy. It's just 8. Duh. But what if I took negative 8 and I squared it? Remember, squaring something means multiplying it by itself. Negative 8 times negative 8 produces 64. If you remember that good old rhyme, you ate and you ate and you got sick on the floor, 8 times 8 is 64. I didn't learn that in school, but students have told me that, and it's kind of clever. If we take 64, that answer, and we put it inside of a square root, what's the square root of 64? The answer is 8. Now if you look, we have 8, and we got 8. So, okay. What if we tried a different number? We can choose anything we want. I'm going to be obnoxious and choose a bigger number, so I'll choose 20. The absolute value of 20 is 20. It's easy. If I try this process with squaring, with exponents, 20 squared is 400. If I take the square root of 400, that brings me to 20. So I get 20 doing this two-step process, and I get 20 by just doing an absolute value. Why would we ever want to do 2, or maybe you can think about 3 steps, because of the mental math, to get the same thing that just absolute values do presto, instantly. Well, that's what I'm going to keep a secret. Keep this little factoid in the back of your mind, because at some point we're going to see this little revelation, and I want you to think about these notes and how we solved absolute values. It's important. So I hope this video helped. Thanks for watching, guys, and we'll see you in the next one. Take care.